talked about a lot of different demand functions or utility functions, consumer expenditure problems, and utility maximization problems. Let's talk about, let's kind of deep dive in deeper into some of these specifics, right? And apply it to the real world. And so this question asks about a utility function and the demand for masks. I thought this would be a good problem because of the world that we're living in right now. I think it would tie in well, right? So this question asks, what is the demand for mask? And that is our Q1. Our P1 is the price of the Q1, so price of the mask. Our Y is our income, and P, and the uppercase P, is our pollution. Sorry I did not write that down. I should have written that down. But yeah, so let's get started, right? We've talked about this before. Whenever we have that, we want to find our MRS, right? What kind of a function does this look like to us? We have a Q1 right here, and we're multiplying it with Q2, right? So this should look like a Cobb-Douglas function to us, right? So this is like a good reminder. Okay, we should know what this is. So now I'm just going to do, okay, what is our MRS? What is our price ratio? One thing to notice, if we are not given like numbers for our price ratio, we very well can write out a general formula. Right, our general formula is that expenditure of good 1 and the expenditure of good 2 is equal to our income, right? And so this is our general formula. You can replace the P1 or the Q1 with an X, Q2 with a Y, but that is our general formula. Just know this on an exam. This is our general thing if we're not given a solid constant for our budgets or for our prices. Okay, so yeah. So now we're trying to find MUX, right? That's a marginal utility, that's a marginal utility of X, in this case, which is Q1, and marginal utility of Q2, right? Here we're taking the partial derivative with respect to Q1, right? And this becomes our constant. And so what we would do is, right, bring that 2 down, take the derivative again, keep what is inside, and this is our constant that stays. That's where I get my MUX, right? Here, again, MUY, this is the derivative that I'm looking at, right? Q2. Bring this down. Keep what this is because this is our constant, right? Bring this down, keep what this is, and this becomes Q2. And that's where I got that from. So take a minute to kind of solve that. And now I'm going to simplify, right? Get rid of this, and this becomes 1, whatever. Get rid of the 2's, get rid of that. And then we are left with a Q2 on top over Q1 minus P, right? So that is my MRS. This is my MRS. Now you're going to be asking, wait, where did the P1 over P2 come from? That's just my budget constraint, right? That's just my price ratio, right? This is my budget constraint. I got that from my budget constraint, and you take out those 2 coefficients, and you get P1 over P2. Now, straight like we did before, just do cross multiplication. And the trick here is, if you want to save yourself a lot of trouble, if I know, like when I'm multiplying this, I get P2 times Q2, right? If I know that this is the same thing as one of our budget constraints, because remember, we're plugging this back into our budget constraint because that is our constraint. Right? We're constrained by our income. So we're always going to be plugging it back into our budget constraint. So would you rather want to complicate things and solve for one variable, or would you just kind of equate the two, right? Because if I know that P2 times Q2 is equal to this junk, I might as well just like plug this back in over here instead of like trying to say P2, solve for only P2 or solve for only Q2, right? Make your life easier on an exam. And so this is what I get, right? I plug this little junk back in over here, and I ended up with this. Now you're just straight up solving for Q1, right? Because that is our end goal. So solve for this utility, and again, solve blah, 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 and then you should end up with this little thing. And by the way, I made my Y turn into an M just because that's what my brain said. But know that in this problem, our Y is our M. Our Y is our income. And this is what you should end up with, okay? The next question I think is pretty cool because it's like an application of your all derivatives and everything that you know. So this is saying, how does quantity of pollution affect the demand for masks, right? So really they're just saying, how does a change in pollution affect, the amount of masks that you will buy? So look at your previous answer, look at this, and all you're doing is that you're taking the partial derivative with respect to your P, the pollution, right? The capital P, right? Because you're trying to see like the coefficient in front of you. You're trying to see, is it negative? Is it positive? Right? Because if the derivative is positive, then your function is increasing, right? So look back to calculus and think about it, right? If you're changing in a positive manner, then your function is actually increasing. And so when I'm taking the partial derivative, right, get rid of that y because it's just a constant, doesn't matter, and you're left with a 1/2. Okay, does that make sense? Right? You have a p1. You would just end up having just that, and you get rid of that p1, doesn't matter because it's just denominator numerator, and you're left with p/2. Derive p/2, and you get 1/2. Oh, 1/2 is greater than 0. Oh, it's a positive number. If your derivative is positive, then your function is increasing. Then your pollution, our function here is our p, that is increasing. Oh, that's great. Okay, so now we know that, the greater the pollution, the higher the demand is for our masks, right? Because it's a positive number. I had population written here. It's pollution, sorry. Okay, so for number 3, it says, how does her income influence the quantity of masks she purchases? Think about it this way, right? This is the same kind of question that's asking, but we're just looking at the different variables. That's really it. Now you're just taking the derivative with respect to income. Our income here is y, right? So it's going to be dq1 over dy, just like this was dq1 over dp. Again, look back at your demand function. So this is why this thing is very important, right? You're always looking back at your demand function, which these functions with respect to all these functions. So when you look back over here, you're left with, okay, this becomes a constant now, right? That y becomes a constant, and you're going to be left with y over 2p1. When you take the derivative, you're just left with 1/2p1, right? Because it's just, the y becomes a 1 because you're deriving it. And so when you see that, okay, that is a positive number, right? That's a positive number. A price can never be negative, right? Then you're like paying money for someone to pay you. It's not happening. So it is greater than 0, right? So that means that the quantity of your masks, right, the amount of masks that you purchase will increase as your income increases, right? Again, the derivative is positive, so the function is increasing. So try to remember calc that way. So yeah. So part D is, what conditions must hold for this assumption that for the assumption that Q1 is greater than our pollution, sorry. How I solve this problem is like, okay, I know what my Q1 is, right? I know my optimal bundle. Where is it? Okay, it was this thing, right? How do I get rid of this? Yeah, so it was this little thing, right? All I did was just plug that back in, right? I know my Q1 is that, and so this is what I have as my expression. All I'm trying to do here is just find, okay, just trying to simplify everything, right? I have a P over here, I have a P over here. Try to get those two together and just solve it and make it an easier expression to deal with, to understand the relationship between Q1 and our pollution. Okay, so I just solved again, right? I multiplied this by 2p1 both sides, and I got y plus p1 times p, sorry, is greater than p times 2p1. Again, y is greater than that. I want to solve for P. I want to have P, pollution, by itself. And I would end up getting 2P1 minus P1. Oh, that's great. I just got, we just simplified it. That's great. And you should end up getting Y over P1 is greater than pollution. So what conditions must hold? Okay, the income over the price, right? The total income that you have over the price of the mask should be greater than our pollution, our function of pollution. That if this holds, then we know that the demand function, the demand for mask should be greater than pollution, right? So if this holds, then this will hold. So that's just the overall gist of an application where you're kind of using a lot of these utility functions, trying to understand, okay, what does this, how does the derivative relate to the actual function? And that should help you with this problem. So thank you.